Hi guys, Mr. Magdad here, the final part of Surds, you'll be happy to hear. So I want to start off by looking at the number one. You've heard me mention previously, whilst doing indices and Surds, that number one is a massively important number. What we want to focus on is the impact of the number one. So first of all, just a little reminder, any unknown value multiplied by one will not change the value. Okay, any unknown value divided by 1 will not change the value. So that's important. That's one aspect that's going to help us in the next phase. The second element is what the number 1 looks like as a fraction. And we know that any fraction that is the same on the top and the bottom is the same as the number 1, or one whole number. Okay, so any set of values you come up with, whether it be 3 over 3 or 28 over 28, or indeed, for the purpose of this exercise, what we've now seen is that surds behave very similar to letters. So if we were to have the square root of a over the square root of a, that would also be the same as 1. So what we're going to do is try and incorporate what we know about the number 1, the fact that when we multiply or divide by the number 1, it doesn't change a value, but multiplying by 1 might be something that allows us to simplify an expression. Okay, rather complex sounding, but what we're going to do now is we're going to teach you how to rationalize the denominator. All that means is effectively turn the denominator, or the bottom value, into a whole number rather than having it as a surd. So we know that whole numbers are rational and surds are irrational. So the way we do that is we choose, first of all, to multiply by 1. And the reason we multiply by 1 is that we're going to take advantage of the sixth rule that you've seen to date, which was root a times root a is the same as a. Okay, so that's the rule that we've used in the previous lessons, and that's going to be absolutely critical when it comes to rationalizing a denominator. So the first step for us to rationalize the denominator in this example, 3 root 7, would be to multiply by 1 and see if we can manipulate or change how the number 1 looks to make that possible. So let's do that now. Okay, so we've, as I mentioned earlier in this video, if we multiply by 1, then that doesn't change the size of the item. It will help us. So we can change 3 over root 7 to 3 over root 7 times 1. Okay, now this is a step that in the end we will remove. Okay, we'll remove this step as you go on, but for the first example, it's very handy to have it in there. Now, how does 1 look? 1, we've seen already that 1 can look like many things: a over a, b over b, 10 over 10. It would make sense for us to select 1 as root 7 over root 7. The fact that we can pick root 7 and root 7 is going to allow us to multiply this root 7 at the bottom. Okay, so we want to select root 7 over root 7, largely because it's the root that's there. And what that gives us, because we know this now because we've tackled fractions, it gives us 3 times root 7 and root 7 times root 7. And that's the critical part, the root 7 times root 7. Root 7 times root 7, we know from rule 6 that that will just be 7 on its own. Okay, so if we take the top, 3 times root 7 is 3 root 7 over root 7 times root 7, just becomes 7, and there we have a rational denominator. The number on the bottom, not under a root, the root 7 times root 7 allows us to remove the root, and we have our final answer. Okay, let's look at a couple of extra examples just to ensure we're up to speed with everything that was involved in that. That all came pretty thick and fast. If we were to take example 8, and if I said to you we want to rationalize 2 over root 11. And what we would do, we would start off by multiplying by 11, root 11, sorry, over root 11. Now, obviously I said to you before that that little step where we multiply by 1 has been removed, so we can go straight to this. Okay, we know that that root 11 dictates that we want to multiply by root 11 over root 11. Okay, so that gives us multiplications on the top, 2 times root 11, so 2 root 11. Root 11 times root 11 is just 11, using that root a times root a rule, and we're left with 2 root 11 over 11, and it has a rational denominator. Now look at example B, and in example B we'll possibly be asked to simplify. So 10 over root 5, and this tells us straight away that we need to multiply by root 5 over root 5. That gives us the top two multiplied by each other, 10 over root 5, and root 5 times root 5 would leave us as 5. Now, what we need to recognize here, any fraction or anything we're dealing with like this, we still have to divide if we can, or simplify by taking out a common factor. 10 will divide by 5, or we could take 5 out as the common factor in that sense, and it'd be a 2. So the final answer would be 2 root 5 on its own. We can't just leave it as 10 over 5. We know that 10 over 5 is a divide, and so 10 root 5 over 5 is 2 root 5.